So my name is Danielle. For those of you I haven't met, I'm an engineering manager at Apollo, and I manage our platform team. And our platform team is responsible for building tools in particular, like Apollo Engine. Have you guys tried out Apollo Engine? Used it? Yeah. I'm sure there are lots of you who've used it. So one of our main goals here at Apollo is to make sure that every single person here in this room, everyone on the live stream, everyone who wasn't able to come today and watches this later, is successful and happy and productive using GraphQL. The developer experience is something that our company cares a ton about. It's something we've thought a lot about. It's something that we're all really passionate about, and I'm sure just as we are passionate about building good tools for everybody here to use, you guys are all passionate about using good tools because you came here. The reason we all love good tools is because it makes our jobs easier, it makes it more fun for us to write code, it makes it more fun to do what we really like doing about our jobs. So when people ask us, what is GraphQL, what do we typically say? GraphQL is a way to communicate between a client and an API. That API is most frequently a server, an endpoint that you're requesting data from, but it doesn't have to be. It could also be, for example, a cache. The main property that's important is that when you send a query in a particular format, you get back data in a corresponding mirrored format that's correct. And so the way we communicate is with a query, as you guys see in this illustration. My talk today is not going to be a typical GraphQL talk as you might expect it, because we're not going to be talking first and foremost about data fetching. While people typically tend to jump to talking about data fetching with GraphQL because that's kind of the whole point, what I want to tell you guys about is what I actually think is more valuable than just the data fetching technical improvements that GraphQL brings to your workflow, and that's actually the productivity side and the tooling side of the benefits that you get from using the GraphQL tools kind of in their full value. So the talk today is not going to be about smaller payloads, it's not going to be about fewer client-server round trips, and it's not going to be about preventing overfetching. Yes, these are all fantastic benefits of GraphQL. These are benefits and reasons why people adopt GraphQL all the time. But adopting GraphQL in your organization, it's non-trivial. It's something that you have to commit to and something that you really have to embrace. And usually when we see companies making the strategic decision to move towards GraphQL, we see it for these reasons. But usually once we see companies having made that transition, already happy using GraphQL, the reasons they come back to us and the reasons they tell us they're happy is because they're more productive. And they're actually more efficient in their jobs, they got this huge boost, and they're more happy. So GraphQL is about helping developers be more productive. The excellent development experience, I think, is really where GraphQL shines, and it's the kind of like the honest reason why GraphQL is so worthy of this investment. Now, what's the most important thing to any company? Looking for shout-outs. What's important to your company?
Good vibes.
Good vibes. All right, what else? Keeping the doors open. Very, very important. And the reason that we keep the doors open is for our customers. The most important thing to any company, I think, can often be derived back to the customer. And how much time, like in your job, is actually spent writing code that's directly valuable to your customer? It's probably not as much as you expect. And there are a lot of reasons for that. I mean, a lot of us spend a lot of our days in meetings. A lot of us spend a lot of our development time doing tech debt reduction or doing planning or getting on the same page and doing alignment meetings. And at the end of the day, frequently, like writing code actually ends up being the easy part. So why is a good developer experience important? Well, it helps us ship products faster. It helps us attract the best engineers that we possibly can to our teams. That's very attractive for recruiting. And it helps us retain those engineers once we've got them because they're actually more satisfied in their jobs. And if we can do all of those things, we'll end up, at the end of the day, building a better user experience qualitatively. So what does a good developer experience look like? Great DX should spark joy, as Marie Kondo would say. Had to throw that in there. So my coworker Peggy, she and I think about developer experience a lot, as does everyone else at this company. And she runs what we call our developer experience team, and she put this tweet out there. She's got a lot of followers, so we got a lot of responses on this tweet. She asked the world, the Twitterverse, what does great GraphQL developer experience or great developer experience look like to you? And we got a bunch of answers. So from about 100 very scientific responses, we kind of boiled these down into 3 categories. Great developer experiences are predictive and intuitive. they're unobtrusive, they get out of your way, and they give you this instant feedback loop. So we were kind of thinking, like, what are some really good examples of tools that we use in the ecosystem that kind of bring us these things? Well, how about React? Do you guys remember, like, the first time React really gave you this wow moment? What did we have before React? Like, sure, a lot of us, we were using handlebars, PHP, Django. I, for example, was just using jQuery. And I remember the first time that I realized that a component could be stateful, and it could unmount and mount itself, and therefore, when I clicked a button or changed a tab, I didn't have to set inner HTML equals empty string on like 15 different elements on my page. Or how about Prettier? So Peggy's actually the one who kind of got me roped into Prettier and hooked into Prettier, because like I didn't really realize that all the time I spent typing spaces was a problem. I just wasn't that bothered by it. I kind of enjoyed making my code look pretty. But Peggy really got me hooked on Prettier, and I can't really express how much time it saved to simply have this like step eliminated from my workflow. Now I just type what I want to type. I click Command Save. I'm sure a lot of you guys are familiar with this. It's done for me. It's simply something I don't worry about anymore. Or how about VS Code? So VS Code's integration with TypeScript, which I'm going to show you later in a demo that I really hope the demo gods are with us for. It's fantastic. Like, as JavaScript developers, we are finally getting the type safety in our IDE that other developers in the industry have been laughing at us for not having for a very long time. And the reason that we love these tools so much is because they solve real problems for us. They help us do our jobs better. They help us have more fun when we're writing our code. And to kind of bring this all back to GraphQL, like, what's one of the biggest problems that we still have today in front-end development? That problem is that we write a lot of data fetching code. Data fetching in React is really not something that React has taken a strong opinion on. And so as a result, when you're using the React programming framework, like, there's not a lot of structure. So people have done a lot of different things to handle data over time. This is a tweet from Adam at Airbnb, who we partner with. So he said in this tweet, of the 2 million lines of JavaScript code in their code base, probably only 10 to 15% of that code is actual business logic or complex interactions. And the rest is just data fetching and styles. And when I read this, I thought, like, that's crazy. That means that 90% of the development that they're doing with more than 1,000 developers at Airbnb is like not directly building value for the Airbnb customers that are like the people in this room and the travelers of the world. Unless you really love their styles, which I also very much admire. So what's the answer to this data fetching messiness? The answer is that you need a dedicated front-end data layer. You need to think about it in a dedicated way. You need to treat it in a dedicated way. And the reason that you need a dedicated layer is because you need to be able to have structured answers to all of these questions. Like, for example, where is the data in my API? Well, in an unstructured world, which is one that I find myself living in a lot, when I need to get data out of an API or make a query, typically what I do is I hop over to my terminal, I write curl commands, I try and find the right combination of the headers and the body, and then once I've gotten my request correct, I put it into my code, I console.log the result to make sure that the data comes back correctly, and then I do that over and over and over again for like every query that I need in my app. And at the time, it doesn't really bother me, but these types of things add up, and they just kind of like pile and pile and pile on us. And we can ask these same questions about each of these things. Like, how do I track loading states and error states in a very managed way? And how do I cache data from my network inside my client state? So when people build applications that become big enough to actually start needing data persistence and needing these types of things, the first thing that React developers tend to turn to is like, oh, we need caching or we need to store that field. Like, let's just throw it in Redux. No big deal. Like, Redux is the closet that we don't want to open, because if we open it, like, everything is just going to fall out. So Redux, like, I'm sure a lot of us have used it or use it at our companies currently. It's a very powerful and elegant programming model, but it's also very simple. And what it is, it's an event emitter. And so you can kind of like emit these events in your front-end code, and then other things can trigger and respond based on that. And while it's really elegant and it can actually solve a lot of our problems, to make it work as a cache, which you typically want to do once you kind of get to the point of making requests over the wire and fetching data and storing it locally, it actually starts to require just a lot of middleware, a lot of packages, kind of like a lot of custom code. And you write a lot more code than Redux has in its source code, which kind of just adds up in the end. So if we optimize the data layer, can we improve the developer experience? For a lot of reasons, I think the next frontier of development for the front end is going to be improving this data layer specifically. React itself has really transformed kind of like the way we build applications for the web, the way we do development in the last 5 years that it's been open source, which is really not even a long time. I mean, they released it, the world has given feedback, they've given updates out about once a year or more with really substantial improvements. And a great example of this is a couple months ago, they released their new React Hooks API. Have you guys used React Hooks? Yeah, oh my gosh, it's a lot of hands. A lot of us have used React Hooks. It's really helped me in my own workflow. I think it's quite ergonomic. So if we can apply some of those principles to the data layer, can we improve our experience? That's the question. And for a majority of the talk, I actually want to do a demo together and show you guys what your GraphQL experience could look like and kind of give you a taste of what we're really aspiring to do here at Apollo. So, let me introduce the concept. So the concept of this demo is we are going to see what does it look like to take a Redux and a REST app and to rebuild that in GraphQL and Apollo. Like, what does it look like? What are some of the differences? Now I'm going to try and pray to the demo gods that my demo is a little bit more lucky than the previous ones. Perfect. Okay, so for this demo, what I did is I went over to the Redux website and I took a look at the examples that they have on that website and said, like, which one of these examples might be a good example to translate into a GraphQL app? And they have an example on that website, which is like a tutorial, and it's called the real world example, and it connects to the GitHub API. And so I thought, like this one connects to the GitHub API, let's use that example for ours because GitHub has a GraphQL API, and it will be very nice. So this is our real world example. If I type in, for example, my username, my GitHub username, the Redux example app, it's very simple. It will go to the GitHub API, it will get my full name, it'll get my avatar URL for this picture, and it will get a list of my start repositories. This page itself is pretty simple, one would think, but what does it actually take to load the data into this page? Is this okay for you guys? Is this big enough? I know the theme is kind of a challenge, and I'm sorry for that. So this user page, it takes in a bunch of props. The most important prop of this whole page is this one at the top. It's called login. And login is what GitHub's API calls my username. So this login prop is being passed in from that input box, and it's loading the rest of the page. Now, for anyone who's built React page-level components before, especially in older versions of React, the rest of this prop object might also look pretty familiar. We have a bunch of the objects required for our page being loaded in, and then we also have functions being loaded in as props that we can use to call the data fetching, which will then get loaded in also as props. So there's kind of a lot of cruft around this because we're managing our own props. Our render function is nice and simple. It just renders our user and it renders our list of start repositories. But the most interesting and the most Reduxy part of this whole file is this map state to props function, and this is a very common pattern. So whenever we need to connect a component to our Redux store, we will use this connect function down here with map state to props. And then map state to props will actually go into our Redux store, it'll take the stuff out of the store, and it'll pass it into our props. So not only for our simple page do we need to define all of these functions to get the right data into the page, but we also needed to define a bunch of actions in Redux. So this file over here in our actions folder is where we're actually doing those data fetches over the wire and then putting the data into the store that the component can read out. So I won't dwell on this too much, but know that the point of showing you the file is that there's a lot of different state management here. There's a lot of repetitiveness. And I think we can do a lot better than this with our example with Apollo and GraphQL. So let's head over to that. Here we go. Okay, so I've staged for us the same file, userpage.tsx. Our file only has two things right now. It has our GraphQL query and our page, which is going to load our user. And right now, if I type my username, it's going to load Jon Snow, the True King. And that's because we haven't connected to our query yet, so it's just passing in these static things. So the first thing we're going to do for our demo is we're going to connect this query to this component nice and simple, and we're going to hydrate it with data. But I don't know about you guys, when I look at this file, the first thing that bothers me is that my whole query is green. Technically in JavaScript, my whole query is in a multi-line string, which is why VS Code has made it all green for me, like every other string. But GraphQL is not a simple string, and so I'm going to enable our Apollo extension and get syntax highlighting on my query, which is much better, so I can actually see what's going on and see my typos and whatnot. And not only that, but I've connected our project to our schema. Our project is schema aware, so not only am I getting syntax highlighting, but I'm also getting like type definition hints whenever I highlight on any file in a query in my client code. So here I hover on the field user. We can see that user is a field on type query. User returns a nullable type user. If I hover on login, we can see that login is a field on type user, which returns a non-nullable string. If I hover over name, we'll see name is a field on type user. It returns a nullable string. I think you guys get it. But not only that, if I go to a new line and hit Control Space, I get autocomplete for every single other field that's in my schema on type user. And the only other field that we need to make our picture show my picture, not Jon Snow's picture, is avatar URL, which is luckily at the top, thanks to the alphabet. So now that we have this, we're good to go. We've got all the data in our query. The next step is to hook this up to actually render into our component. And to do that, I'm going to use our brand new React hook from Apollo React Hooks, which has only been available in a official build for a couple weeks. It's very top of the line stuff. Okay, so we're going to call my hook with my query. And we're going to pass in my login. And from this function, from this hook, what we're actually going to be getting is a few properties. So one of those properties is the data that actually comes back from the query. Another property is this loading flag. Another property is this error flag. And we can actually use those things to render loading states. So if loading is true, because loading is a Boolean, we'll return a loading flag. And if there's an error, we should return that as well. Also, if you guys spot any typos, please let me know, because demos are very intimidating. The last time I did a demo, I forgot an S, and it was very embarrassing. Okay, so if it's loading, we'll have loading. If it's an error, we'll have our error message. Otherwise, though, we should actually just be able to destructure those properties from our query. Okay, so if I hit Command Save, fingers crossed, this will reload with my picture, which it does. Sweet. Okay, so that's the use query hook, brand new, super fun to use, you should try it out. But the next thing I want to show you is Apollo CodeGen, which is very magical as well. So over here, I've got a types.ts file, and in the background, I've got our CodeGen running in watch mode, which means that it's looking at all of the code in our project, it's extracting queries every time a file is saved, and it's generating TypeScript definitions based on what's in those queries using the data that it knows about our schema to create Typesafe types for our queries. So what's going on here is if I add, for example, email, and I hit Command Save, you might have noticed that this kind of got automatically generated, automatically populated. If I remove email and I hit Command Save again, now it's gone. So we're going to use these types in our code to provide type safety to our query to make sure that we didn't make any mistakes. And to do that, let's import our types from the file, and then we will pass them to use query. And the reason we do types.user is because we named this query user. So if I hit Command Save, we should see an error, and it's a TypeScript error. And I don't know if any of you guys noticed, but at the same time, VS Code started giving us these warnings because we've actually done something here that's very unsafe. And what's unsafe is that data can possibly be null, and we have access to the user field on that object in an unsafe way because we didn't check for nullability. And not only that, the user can also possibly be null according to our schema. So we've also accessed all the fields on user in an unsafe way. So thanks to TypeScript, we've caught this, and we can add a nullability check. If there's no user, we will return not found. Wah, wah. And if I Command Save again, our swigglies have gone away. We're good to go. Now we can proceed. Now, I don't know about anyone else in this room, but I think I speak for a lot of front-end developers when I say that it's very easy to forget nullability checks in JavaScript code. And it's especially easy to forget this when you are consuming like properties off of queries where you're not pedantically checking whether or not your fields are nullable on the types in the queries. So it took me actually several months of developing with GraphQL to even realize from another developer in a code review that I should be doing nullability checks. I don't know why, that just didn't occur to me before. But thanks to TypeScript, we actually saved a bug that I probably would have personally shipped into production. I've even shipped bugs like this into production before. So the last thing I want to show you all is Apollo client local state. And this is what I think is actually one of the most powerful parts of Apollo client and probably also one of the least well known. So the idea behind Apollo client local state is that we as front-end developers can extend the schema that we're getting from our remote server with other things that we want to add to it that do not exist in the remote server. And this is actually really commonly used for things like maybe you want to store fields persisting across sessions, like the last tab that the user looked at. So when they come back to your application, you can kind of load them up where they left off. But my favorite use case for extending the schema on the client side is that this actually provides a really powerful mechanism for doing mocking when you're trying to build a new feature that doesn't exist. So typically when we build new features internally, and I think this is pretty common in the industry, the first step that we do is we decide what our schema is going to be. And once we've decided what our schema is going to be, now we have kind of like a Typesafe guide. And we can both build to that specification on the back end and trust that specification pretty strongly on the front end so we can build scaffolding for our components and be pretty sure that it's going to hook up pretty closely. So what I want to add to our schema is this field is true king, because I want to know if I'm a king. And if I hit Command Save here now, obviously we're going to get this error back, is true king doesn't exist on type user, because why would it? It doesn't exist in the remote. But this is where we're going to go over and actually define is true king on the front end. So the first thing we're going to do is we're going to define some front end schema. And we're going to extend type user with is true king, which is going to be a Boolean. So now, actually, if I go back to my user page, you'll see that the squiggly is gone from VS Code because VS Code has been smart enough to identify that I extended the schema on the front end, and it's actually merged these two things together. But I haven't defined the resolver yet, and so it's still not going to be very useful. What should is true king return? Well, I don't know if you guys are happy about the state of Game of Thrones after that finale. But we all know that every time a Targaryen is born, a coin is flipped as to whether or not that person will be a good king. So our is true king function is going to return a 50% chance that any given user is the true king. And down here, the last thing we have to do is add these resolvers that we just defined to our client. So now if I hit Command Save, this error should go away because we've defined is true king on our type user and it exists in our schema now. And the last thing we have to do in our demo is to use this. my CodeGen died. Oh, yeah. Let me restart CodeGen real quick. Do you guys see the problem? What was it? Oh, no, it's gone. So it was just CodeGen. Oh, okay, good. Well, I'm not the true king, but if I refresh this, I think I can be the true king. Okay, so I want to leave you guys with some thoughts. So I'm going to stop mirroring and put my slides back up. If I can figure out how to do that. Yeah, we're good. Okay. So thought number one, the example that we went through, replicating user page, that was just a small portion of the Redux real-world app. But I actually went out and built the rest of that app, like a full replica, which you can see on GitHub. And not only was it 12 files to build that app in GraphQL and Apollo instead of 17 files with Redux and REST, but those files had a combined total of 251 lines of code instead of 700. And that's actually substantially less because the lines of code in our version included our type defs, which is generated code, which is a lot of code. So this fully replicated version of the Redux app was about 35% of the size. And the last thought that I wanted to leave you with is that our data layer is only going to get smarter over time. We're going to continue to keep working on this, continue to try and make the experience for you as impactful and productive and fun as possible. And that's only just going to keep uncovering new problems and new frontiers along the way. So what I've just shown you is like just scratching the surface of what we want to do. Building features should really be as simple as writing queries. That's how we think about it. That's how we interact with GraphQL. I really feel like that's what we deserve as developers on the front end. We should be able to write a query, and that's it. So if you guys have any questions, come find me later. I'm Danny Man on Twitter with 2 M's. I love talking about GraphQL, so thank you all for listening.